Welcome to Learn PTE HUB. I'm Sidhu, and I'm here to help you ace your PTE exam. Whether you are just starting your PTE journey or looking to boost your score, you've come to the right place. On this channel, you'll find comprehensive lessons, expert tips, and practical strategies to master every section of the PTE exam. Don't forget to subscribe and hit the bell icon so you never miss an update. Let's get started and conquer the PTE together.
A sea breeze is an onshore breeze which develops around the coastlines of sea and even large lakes on warm days. In mid-latitudes, it commonly occurs during the spring and summer. This is when there is a large temperature difference between the sea and adjacent land areas. A sea breeze is a thermally driven circulation, forming due to the fact that the land heats up more quickly than the sea. Water has a higher specific heat capacity and so requires more energy to raise the temperature. As the sun radiates energy at more or less a constant rate, it will take longer for the water to heat up. This means that peak sea surface temperatures aren't reached until early autumn. This differential heating of adjacent land and sea surfaces is the main factor in the formation of sea breezes. A temperature difference of around 3 degrees Celsius is required for a sea breeze to start to develop. Other factors that are required for sea breezes to form are light offshore winds at around 3,000 feet. This aids the higher level flow out to sea to get the process started.
In Central East Africa, there lives a small, slow-growing, scruffy tree that residents call mpingo, from the Swahili for the ebony tree. Mpingo is true to its namesake, with wood that ranges from reddish to pure black. Mpingo wood gains remarkable stability from the layer of sapwood that divides its bark from its inner hardwood. Its hardiness has been a factor in both the tree's success and its endangerment. For the last 100 years or so, mpingo wood has been the primary material used to make clarinets and other small woodwind instruments in many commercial markets. But mpingo trees take 75 to 100 years to reach harvestable size, and rates of harvest have far outstripped the tree's slow growth. One 2009 study found that poor conservation had left these grassland trees with low germination rates that result in decreased biodiversity. The trees need gene diversity to keep their populations productive. It's important to point out that this blackwood variety of African rosewood came to popularity after the Central American ebony cocos wood was depleted in the 1900s. It had been the staple for woodwind instrument manufacturing up to that point. But in Tanzania, where mpingo is the national tree, conservation helps to keep it from being threatened. One effort, called Clarinets for Conservation, uses music education to inform young Tanzanians about the importance of their national tree and how to get involved in protecting natural resources. Also, farmers plant mpingo in lowlands where the tree can easily withstand grass fires that other plants often cannot. Their efforts help the tree of music to continue to thrive.
Try telling someone who has just fallen on a patch of ice that ice is not slippery, and they'll think you're crazy. But in fact, ice itself isn't slippery because it's a solid. One quality of solids is that when two solids are together, there is friction between them, and that will keep them from slipping. So, how can your shoe slip on ice? The answer lies in two peculiar properties of ice. The first is that as water freezes, its molecules move farther apart. The molecules of most substances move closer together as they freeze, making them shrink at lower temperatures. But water molecules move farther apart at temperatures below 39 degrees Fahrenheit, making water expand as it freezes. That's why frozen water pipes burst, and a tray of ice cubes will freeze over its top if you fill it too full. The second peculiar property of ice is directly linked to its first peculiarity. When subjected to pressure, ice melts. Remember that the molecules in ice are farther apart than the molecules in water. Therefore, ice molecules are vulnerable to pressure, which pushes them closer together, causing the ice to change into water. So when you step on a patch of ice, you exert pressure on the ice, which causes its molecules to move closer together. That makes them revert to their more dense state, which is water. If you slip on a patch of ice, then, you in fact are slipping on a thin layer of water that the pressure from your weight has created, and unlike solid ice, water as a liquid is quite slippery.
Greenhouse gases act as a layer of insulation, trapping some of the sun's warmth before it is released back into space. This process is known as the greenhouse gas effect. The primary greenhouse gases from energy production and consumption are methane and carbon dioxide. The rate at which we have added greenhouse gases to the atmosphere since industrialization is the leading cause of climate change. Climate change is causing extreme weather events like droughts, floods, fires, and hurricanes. These events will increase in frequency if we do not reduce emissions in the atmosphere. For much of human history, greenhouse gases in the atmosphere have been kept at safe levels by natural carbon sinks, such as oceans, forests, and wetlands. However, we are now adding greenhouse gases to the atmosphere faster than natural carbon sinks can absorb them. When people talk about climate change, they often reference the average increase in temperature around the world. For instance, the Intergovernmental Panel on Climate Change, the IPCC, has recommended a cap of 1.5 degrees Celsius as the maximum amount of average warming that can happen while maintaining a safe environment for people.
Homes are usually the largest purchase of a lifetime, so every home should stand the test of time. Zero energy ready homes to the rescue. They are designed, constructed, and certified to the federal government's most rigorous guidelines for efficient, healthy, comfortable, and durable homes. This is accomplished with 3 proven innovations that help every homebuyer get the most from their new home. Innovation number 1 is maximum protection construction. This includes industry-leading best practices for roof, wall, window, and foundation assemblies that protect against heat, cold, drafts, and moisture. Innovation number 2 is advanced technologies. A comprehensive technology package helps your home work better and last longer. High-performance heating and cooling deliver total comfort. ENERGY STAR labeled products save money while exceeding performance expectations. And solar-ready construction allows a solar electric system to be added in the future with no cost, penalty, or disruption. And finally, innovation number 3 is certified performance. Each home is independently verified to meet all the requirements for 3 national high-performance home programs. ENERGY STAR Certified Home ensures a strong foundation of above-code efficiency, comfort, and water protection. Indoor Air Plus certification ensures a comprehensive package of health measures that help you breathe better. And Zero Energy Ready Home certification optimizes performance and efficiency so annual energy consumption can be offset with renewable energy.
If you did, please give this video a thumbs up and subscribe to the channel for more PTE-related content. Don't forget to leave a comment below letting me know what you think or if you have any questions. Thanks for watching. I will meet you soon at our next video.